Ever wondered how you make something? I mean, something the size of a school bus, screaming through the sky at nearly twice the speed of sound, just vanish? That's the whole magic trick behind stealth technology. And, it's not actually magic. It's an absolutely fascinating mix of physics and material science. All right, so let's get right into it. This is the big question, right? How do you make a 30-ton aircraft invisible to radar? I mean, we're talking about a huge, fast-moving hunk of metal. So how on earth do you hide it from the very thing that's designed to spot it? That all-seeing eye we call radar? So to really get how stealth works, first we've got to understand what it's up against. Think of it like the most high-stakes game of hide-and-seek you can possibly imagine. And the seeker? It's an electronic eye that can spot you from hundreds of miles away. The basic idea behind radar is actually pretty simple. Imagine you're in a pitch-black room, and all you have is a flashlight. You shine that beam around, right? When the light hits something, it bounces back to your eyes, and boom, you see it. Radar does the exact same thing, just with radio waves instead of light. It basically yells an electromagnetic pulse out into the darkness, and then it just listens for the echo. Now, the name of the game here is something called radar cross-section, or RCS for short. You can think of it as the stealth score for any aircraft. If you've got a high RCS, you're super easy to see. You're like a giant bright flare on the screen. But a low RCS, that means you're faint, really hard to lock onto, maybe even totally invisible. So the entire goal of stealth is to shrink that number down to almost nothing. And this really puts it into perspective. A regular old fighter jet, with all its sharp angles and flat surfaces, it reflects radar waves like a massive mirror. Seriously, on a radar screen, it might as well be a flying barn door. But a stealth aircraft, its RCS is closer to a tiny metal marble. So the big question is, how in the world do you shrink a barn door into a marble?
Well, it really boils down to two main strategies. These are like the golden rules for staying hidden. Rule number one, you shape the aircraft in a very specific way to bounce the incoming radar waves away from the person listening. And rule number two, you cover it in special materials that just soak up the radar waves, turning them into a teeny tiny bit of heat.
Here's a great way to picture it. Imagine you're trying to put something into a perfectly still pool of water. If you just chuck a big rock in, what happens? You get a massive splash, right? Well, that splash is like the radar reflection from a normal jet. Stealth technology, then, is the art of designing something that can just slide into that water so smoothly, so gently, that it makes almost no splash at all. No splash, no one knows you're there. Okay, this is where it gets a little wild, but stick with me. Even empty air has a kind of electrical resistance. It's called impedance. Think about pushing your hand through water versus trying to push it through, say, thick honey. They have a different feel, a different resistance, right? So when a radar wave is cruising through the air and suddenly slams into a piece of metal, that huge change in texture causes a massive reflection. That's our splash. The trick, the real secret sauce, is to coat the plane in something whose electrical texture perfectly matches the air's. If the radar wave feels no change, it just glides right on in and doesn't bounce back. And that brings us to the real magic behind the curtain, the special radar-absorbing materials, or RAMs. These are the things that make it all possible. And the hunt to create these materials, it has a surprisingly long and really cool history.
Yeah, this idea is definitely not new. Way back in World War II, German engineers were already playing with this stuff, making rubber sheets packed with iron powder to coat submarine periscopes, all to try and hide from Allied radar. And get this, in the 50s, there was a material called spongex, literally made from carbon-coated animal hair. It was used to build rooms that were completely silent to radar. So yeah, the science here has been cooking for a long, long time.
So these materials pretty much fall into two main categories. First up, you have what are called resonant RAMs. These work a lot like your noise-canceling headphones. They're designed to create a little echo inside the material that's perfectly out of sync with the incoming radar wave. And what happens? They just cancel each other out. It's an incredibly smart trick. Then there's another type, which is all about absorbing the energy slowly, kind of like a car coasting to a stop on a really long off-ramp.
And here is a perfect example of that slow absorption method. Look at these pyramid shapes. There's no flat surface for radar to get a clean bounce off of. Instead, the waves get trapped down in those valleys, bouncing back and forth, and with every single bounce, they lose a little more energy until poof, there's nothing left to escape. It works exactly like those foam wedges you see on the walls of a recording studio to trap sound.
Okay, let's circle back to those resonant absorbers, the noise-canceling ones. On the left, you see a pretty simple version. This is like having a shield that only works against one specific type of weapon. I mean, it's effective, but it's limited. Now, look at the design on the right. That's what's called a Jamin ram. By stacking a bunch of different layers, you're basically setting up a whole series of traps. Each layer is perfectly tuned to a different radar frequency. It is a way smarter, way more flexible defense that can deal with a whole bunch of different radar waves coming at it.
And all this history brings us right up to today, to the modern era. Because the latest breakthroughs in stealth, they're not just about clever layering anymore. Now it's all about revolutionary new materials. And a lot of them are based on one of the most basic elements there is, carbon. Today's absolute cutting-edge rams use these advanced carbon composites. We're talking about things like carbon fibers, which are insanely strong and light, and even stuff that sounds like it's straight out of science fiction, like carbon nanotubes and graphene. And these aren't just tiny little improvements. Oh no, these are total, complete game changers for the world of stealth. Now just look at this number for a second. 0.35%. It looks so tiny, right? Almost insignificant. But what this number represents is absolutely massive.
Here's why it's so important. To get the same stealthy effect, you used to need a material that was, by weight, 20% of an older material called carbon black. But with modern carbon nanotubes, CNTs, you only need 0.35%. That is a huge reduction in weight. And less weight means a lighter, faster, more nimble aircraft. It changes everything. A total game changer. No question. Okay, so let's tie this all together. We've talked about funky shapes, some wild physics, and a whole lineup of materials from basic iron filings all the way to futuristic nanotubes. So what's the big picture here?
This table kind of sums it all up really well. You've got your pyramid shapes, which at the end of the day just trap the radar wave and wear it out. Then you've got the layered Jaumann design using that clever noise-canceling trick we talked about. And finally, you have the super advanced stuff, the carbon nanotubes and graphene. Now don't worry about the technical terms here. They basically just work by making the radar wave's energy vibrate itself away into a little puff of harmless heat. Different methods, but they all have the exact same goal. Just disappear.
You know, when you think about it, from coating submarine periscopes back in World War II to now, where we're basically weaving aircraft skins out of graphene, this whole quest for invisibility has always pushed science to its absolute limits. Which it leads to one final, really fascinating question. As these materials get even smarter, even lighter, are we actually heading towards a future where perfect invisibility, I mean to every kind of detection, is no longer just science fiction?